Today we're going to talk about filtration. So probably the most important thing you need to know about filtration deals with the nitrogen cycle. And this is a very simple way to depict the nitrogen cycle. But what you need to know for an aquarium is once you put your fish into an aquarium, if you don't plan properly, all your fish are going to die. This happens all the time. I used to work at a pet store before while I was in college, and this is the most common death for aquarium fish is people would go to some other store and they would buy a whole bunch of fish, throw them in their tank turns cloudy, all the fish die. It happens a lot. I still see students do that, graduate students, and they'll come to me and say, hey, I'm doing this project and all my fish died. All right, well, the reason is because you can't just throw a bunch of fish in an aquarium and not consider the nitrogen cycle. So, for example, you set your tank up, you put in a substrate, all the filtration equipment that you want, and you put your fish in. What you're going to want to start with is one animal. It doesn't have to be a fish, but it should, if you're going to, let's just use fish to make it simple. You're probably going to want to put in 1 or 2 fish at the most, depending on how big the tank is, and then wait at least a month before you put anything else in. All right, here's why. So let's say I set up my new tank, I put in a couple fish, and what happens is just through their natural daily processes, they're going to produce ammonia as a byproduct. All right, so that ammonia levels will start to rise in the aquarium. And the ammonia is toxic. It'll kill your fish. If it gets too high, tank turns cloudy, you can actually smell the ammonia in the water, and your fish will die. But what happens is there's a nitrifying bacteria that lives in any aquatic environment. It'll just show up and start growing. But in your aquarium, it'll show up. You could artificially introduce this bacteria by taking gravel from an already established aquarium, or you can just buy it in bottled form and dump it in regularly. But generally it takes at least a week for that bacteria culture to get going. So here you can see the ammonia levels rising. Now, as that bacteria grows, it lives on the ammonia and it'll convert it to nitrite. So here you see the ammonia level starting to decline as our bacteria culture grows, and that ammonia is being converted to nitrite. Here it is climbing higher and higher and higher. Now, nitrite is also considered toxic to your fish, especially freshwater fish. They can develop what's called brown blood disease, meaning that the hemoglobin on the red blood cells will no longer bind to oxygen, and they literally can just suffocate and not enough oxygen. But it's toxic for salt and freshwater fish. So here's your nitrite increasing in higher and higher levels. Now there's also another nitrifying bacteria. So Nitrosomonas converts ammonia to nitrite, and then Nitrobacter converts your nitrite to nitrate. So here you see that bacteria culture starting to grow. The amount of nitrite in the tank drops quickly, and your levels of nitrate will begin to increase, and they'll just keep growing and growing and growing. You'll just keep getting more and more nitrate in your aquarium. Now, there are ways to handle it. In most freshwater only, freshwater fish only tanks, you're going to see nitrate continue to rise. And it's not really toxic to your fish. You don't want it super, super high, but it's not going to be a problem within your aquarium. Unless you have some sensitive invertebrates, corals and other things, they don't like it. It also encourages the growth of algae, including nuisance algae, which can smother your corals and sensitive invertebrates. So you want to get the nitrate out. But really the best way to do that is just do your regular water changes, and you'll get that nitrate out of the aquarium. If you have a fish-only system, depending on the type of filtration system you have set up, when you test your water, there's a chance that you're going to see nitrates. They're going to be completely off the scale. Don't freak out. I would see this too a lot when I was working at this pet store. People would come in like, yeah, I tested my nitrates. They were off the scale, and I did a bunch of water changes, and my fish died. All right, well, it's because they did a bunch of water changes. Fish do not like abrupt changes in their environment. They like very, very slow changes. So your water changes need to be small, 20%. Okay, you don't want to do 100% water change because your nitrates are real high. So that's another problem. So how long does this all take? Well, after about a month, okay, you can see there's days on the bottom here. And after about a month, your nitrites will be low enough, and there's these bacteria culture handling the ammonia and the nitrite. You can add maybe a couple more fish. Then your tank's going to go through another series. You'll see another spike in ammonia, which will drop, another spike in nitrite, which will drop. And then you can add a few more fish, and then wait a month and add a few more. Now, again, you can speed this up by artificially introducing these bacteria into your aquarium, but you need to do water tests to determine where you are in the nitrogen cycle. All right, here's another way of depicting the nitrogen cycle. So here's your fish. You add your fish to your aquarium. It's going to produce waste or even overfeeding. If you feed your animals too much, what will happen is the food will sit on the bottom and rot and again produce ammonia. If a fish dies, hides under a rock somewhere and dies, again, it's going to start decaying and produce ammonia as a byproduct. Now, here's that Nitrosomonas. This is that bacteria that'll grow in your aquarium. Converts the ammonia to nitrite. The Nitrobacter will convert the nitrite to nitrate. And this is pretty much the end of the road if you have a fish-only tank. Now, there are ways to handle nitrate, and we'll get to that later on. But it's generally in a fish-only tank. It's just going to keep building up and building up. If you have algae in your system, they will take up the nitrate, and if you use live rock or there's other means, which we'll get to later on, they can handle that nitrate as well. But for a fish-only tank, you're doing water changes to remove. One of the reasons you're doing water changes to remove that nitrate. All right, so filtration can be broken into 4 categories: mechanical, chemical, biological, and physical. And most often when people think of filtration, they're thinking of mechanical filtration, but by far the most important type of filtration by a huge margin is biological. So I'll talk about mechanical first, and I'll describe all these in more detail, but a general overview is mechanical is going to remove any undissolved particulate matter by trapping debris or sand, or there's polyester pads that you can put in your tank. So the water's flowing through some sort of a pad or something that's going to physically screen the water for large particles, which can be removed. And the reason you're doing that is because those large particles will decay, produce ammonia, and so forth. So that's mechanical. And chemical filtration is using usually carbon, activated carbon, that'll actually absorb pollutants by absorption or adsorption. Or ion resin exchange is another common way, but you put some sort of a media into the flow of your filtration system, and the water needs to be forced through it, and it'll pull out things that are really like things with a charge. Like I said, activated carbon is probably the most common. There's different grades of activated carbon. You can get research grade, which is very expensive, works very well. You don't have to change it as frequently. Or you can buy super, super cheap activated, well, super cheap's relative, still pricey, but you can buy the cheap stuff and it still works, but you need to change it regularly, or what can happen is the things that it's absorbing, the carbon will start to break down, and things you've absorbed will just they'll leach back into the water. So you need to change your activated carbon regularly. Another very common type of chemical filtration is called zeolite. So the activated carbon, like little black rocks, are super dusty, and you have to rinse them really, really well. You're probably in the lab already. Maybe you've changed some activated carbon already in your filtration system. Make sure you rinse it really, really, really well for a long time, because if you don't, it'll turn your tank black. The white rocks are called zeolite. Zeolite is similar to activated carbon, but it's particularly good at absorbing ammonia, actually. So if you see a really big ammonia spike and there's like a super big emergency, I need to remove a bunch of ammonia real quick. Sometimes people use zeolite. All right, biological filtration. So I've talked about this already, but this is the nitrifying bacteria that's going to transform those toxic nitrogenous wastes into less toxic forms, such as nitrate. And a lot of the filters, in fact, all filters should have some surface area to house these biological filters, this biological filtration. The bacteria need a place to grow. So that can be in this form of sponges, which have teeny tiny little pockets that will allow lots of nitrifying bacteria to grow, or there's other mechanisms. We'll talk about that. The last group is physical filtration, and this is going to include protein skimmers, ozonizers, and UV sterilizers. I'll talk about protein skimmers. They work really, really well with salt water. So you may have seen these big tubes in part of the filtration system that has a bunch of water flowing through it, and there's air injected into it, and so it gets real frothy, and the bubbles will collect more than just protein, really. Any organic compounds will stick to these tiny little bubbles, and they can be collected, and you just get rid of it. So it pulls out a lot of this organic waste. It doesn't work as well with fresh water, and that's because of the density. Fresh water is not quite as dense, so the bubbles aren't as small, and it doesn't work very well. There are some cases where it will work, but usually not. Ozonizers, basically you're injecting ozone into your system that burns up anything that goes through there. And then UV sterilizer, same thing. You're running the water plumbed in line with your filtration system. It'll go through a tube that has some UV light that just burns up anything that goes through there. So I'll talk about all of these in a little bit more detail. All right, so this is a very, very simple type of filtration system. So here's the home aquarium up here, and you've got you're draining the water off in some way, and it's actually coming through this tube here down into this drip tray. These used to be very popular, maybe, I don't know, 20, 10 years ago. But maybe 10 or 15 years ago, people started switching more to these filter socks. It just looks like a big sock, really, that the water flows through, and then you have to change them out frequently, because it's a form of mechanical filtration. It's collecting a lot of this detritus. You pull it out, you can rinse it off in the sink, maybe run it through the bleach bucket to get any burn up any organic stuck to it. But these drip trays are actually making a comeback. People are starting to move away from the socks and starting to come back to these drip trays. Here's how these work. There's a filter pad. You can see that big square pad right there. Water flows down into here, and then this is a tray that slides out, and there's little holes in the bottom of it. So the water literally is dispersed in this drip tray, which drops through this styrofoam container here. Is a homemade biological filtration, and inside this, we could call it a bio tower, are going to be tiny little bio balls, and these are engineered to have lots and lots of surface area, and the water will run over these. These stay wet. They're not submersed, but they stay wet, and nitrifying bacteria grows all over them, which will handle your nitrogenous waste. There's some criticism. I mean, they can trap detritus and things, organics that get through your drip plate here or filter sock, and they can end up making lots of nitrates. But that's the bio balls. All right, there's the reason that they're not submerged is because they actually use up huge amounts of oxygen. The nitrifying bacteria do, and so they need that exposure to the air. Here you can see a couple other pieces of filtration. So there's that hose. Here's the home tank here. There's that hose draining down to the sump, which is this stuff down here. And water drains through the filter plate, past through the bio tower, down into the sump here below. And down in the sump, you can add other things. You can see a protein skimmer down here. There's ozone being injected into this system. There's heaters down here. So sumps are a place where you can put all that kind of stuff. And then there's going to be a return pump you can see it plumbed here, returning back to the home tank. And on its way back, it may go through a UV sterilizer. And this is the return line here, is pressurized. Okay, the drain is not pressurized, but the return line is. It's going through this unit here is a type of chemical filter. So inside this, you could put your zeolite, you could put your carbon, or that kind of stuff. This thing here is a calcium reactor, and that just adds calcium to your system. And we'll talk more about how different ways you can add calcium later on. But because tanks with corals and certain invertebrates need lots and lots of calcium added. All right, so that's this chemical filter here, and then returns to the tank. Here's another type of simple homemade biotower. This is our shark tank. We've reconfigured this several different times, but basically it's the same thing. So we're taking water from the sump here, and it's just being or from the tank itself, and it just runs over this. There's some mesh filter floss in here. This is the mechanical filter. Water drains over the bio balls. That's your biological filter down into the sump. There's your skimmer right there. That's a physical filter. There's lots of different types of protein skimmers. Again, you'll see them around the marine lab. Here's another type that hangs on the back. Some work better than others. The technology keeps getting better and better. If you have one that doesn't function very well, it's very frustrating. They're very, very difficult to adjust and to keep running properly. They need constant tweaking, and you got to mess with them all the time. But eventually, I mean, if you have a tank with a protein skimmer, it just takes some practice and some fine tuning, and you'll figure it out eventually. But basically, what you're doing is water's being pumped out of the tank here. It gets frothed up, and all the dissolved organics will be collected to tiny little bubbles, which are pushed up into this collection cup here, and then water will flow back into the tank there, and the foam just keeps getting pushed up. New foam is formed. It pushes the old that's already got stuff stuck to it, and you collect it in here. You collect this black looking goop, and you want to adjust them so that you're collecting what's called a dry foam. You don't want like wet water pouring out of this thing. You need to dial it down enough that this foam is being pushed up and collected. It looks disgusting. It looks like fish waste, but it should smell like fresh dirt. So it shouldn't smell bad. You got to pull this thing off and clean it occasionally. Sometimes I'll drill holes in the collection cup so I don't have to keep taking them off, and then run an air line down to a collection cup. The ones that they make today, usually it comes with something like that, so you don't have to drill your own holes. But that way you don't have to keep taking this thing off. It'll just collect most of the skimmate down here in a little bucket or a jar or something. You just dump it out regularly. All right, here's another type. These things are these are horrible. This is called a cyclone. Well, some people, and you'll run into this on occasion, some of these skimmers, they just don't work very well. And so the way you can make them more productive is to literally drill a hole in the top of this, stick a rigged tubing air line down in here, and you would put an air stone, a special type of air stone made of either lime wood, which they dissolve over time, so you got to replace them frequently, but they produce teeny tiny little bubbles that again the water dissolved organics will stick to, and you can collect it in the collection cup up here. Or ceramic air stones, which are actually very, very expensive, but they're worth it because you don't have to change them quite as often. You'll still need to change them. They'll get clogged up with calcium and other stuff. But all right, water chemistry. So you're probably doing some water tests, pH, temperature, ammonia, nitrite, nitrate. Ammonia and ammonium, for those of you who've taken chemistry, depending on the pH, the ammonia will shift between these two forms. So there's the ionized form NH4 and then the unionized NH3. The ammonia is more toxic than the ammonium. but what we're concerned about is ammonia. Some tests you can test for both, but we're more concerned about ammonia, which again is converted to nitrite, which will convert to nitrate. And so some general guidelines. If you have a saltwater aquarium, you want your pH at about 8.2, but as long as it's between 8.0, 8.5 is pretty extreme. It's hard to get a pH that high unless you're adding something in properly. But normally it should stay around 8.2. Freshwater tanks typically are going to be around 7, unless your fish have particular needs. There are some freshwater fish that like pHs around 6, or there's some like African cichlids that prefer a pH at about 8.2, just like a saltwater fish. So know your animal's requirements, especially if you're trying to breed. Let's say you get discus or something, and you're trying to breed these really delicate freshwater fish. You need to be very, very careful about what the pH is, and you're going to be needing to add buffers to keep that pH stable on a regular basis. Temperature, usually about 78 degrees is the rule of thumb for tropical fish. So most of the fish we have that we keep and that most people keep are going to be tropical fish that are going to be between, it's 75 to 80 is really, 72 is pretty low. Unless you have a goldfish or something, they don't mind temperatures that low. But if it's below 75, that can be a problem. 78 is probably what you want. If you go over 80 degrees, sometimes people intentionally increase the temperature slightly to induce breeding and so forth. But in my experience, over 80 degrees, and you're going to start seeing a lot more nuisance algae blooms. So unless you have a very good reason for keeping your animals over 80 degrees, I would shoot for about 78 and keep it stable. Again, fish like very, very stable conditions. They want whatever your pH is, it needs to be stable. Whatever the temperature is, it needs to be stable. Ammonia there should be no ammonia. There should be no nitrite. And nitrates may be okay, depending on what you have. If you have invertebrates, you don't want any nitrates, and you have a filtration system that'll handle that. If you just have fish, it's probably okay. Just keep doing your regular water changes. But if you want to keep them, if you need a number, keep them below 25 parts per million. But don't freak out if it's higher than that. There's lots of different types of tests. In the marine lab, we use drops. They're the cheapest, and they're fairly accurate, so we use them quite often. And so the instructions are different for each kit. You might just have to read them, but usually it'll be a little beaker or a little vial. You're going to put 5 milliliters of water in. Then you may add, let's see, reagent 1, shake it up a little bit, let it sit for a minute or two, add reagent 2, shake it up, let it sit, add reagent 3, let it sit 5 minutes, it'll turn a color, and then you match that color up to some color chart that came with the test kit. And so let's see, usually you get about 3 reagents for the ammonia. There's usually 2 for nitrite. pH, there may just be 1 reagent. But make sure the test kit for pH is the right one. Make sure you're using, they make high range kits and low range kits. So usually if you have saltwater, you want a high range kit, or if you have African cichlids, you have a high range kit. Most freshwater fish are going to use the low range kit. If you have tablets, so these are called dry tabs, it's the same thing. There's usually going to be, I think ammonia, there's typically 2 tablets, and you just put one in, shake it up until it dissolves, put the second one in, shake it up until it dissolves. They're convenient. They work pretty well. And you can buy dry tab kits for most of these of the common tests. They're a little bit more expensive, so I don't use them. I used to use them, but I think they're any more accurate than the drops. There are many other types of test kits. There is photospectrometers that you take a sample and you get a reading from a machine. It'll give you a number, actually a digital readout that'll tell you what these levels are. And we use a few of those. There are you have a pH pen, or there's other types of probes, okay, that you can use. But in the marine lab, we mostly use the drops. All right, so there's a close-up. There's ammonia 1, ammonia 2 dry tabs. And again, make sure you're using the right chart for the water test that you're using. You don't want to use some other company's color chart because they're all individual. All right, now one of the first types of filtration systems I want you to know about is the undergravel filter. This is by far, in my opinion, the best type of filtration system for a fish-only tank. We used to have them in all of our aquariums, but I had a lab coordinator that didn't like them, and he ripped them all out, and they're really difficult to put back. So I've never replaced them. But here's how this basically works: you have a filter plate that raises off the bottom by half an inch or so. So it's not actually touching. I mean, this part here is touching the outside rim is touching the bottom, but there's a space here between this plate and in the bottom of the aquarium. Then what you do is you put in your uplift tubes, which rise up to near the top of the tank. Then you're going to insert these rigged tubing. At the end, there's an air stone. You need to couple this with a little section of air line. And then you can hook up another air line here, which will go to an air pump. These are little carbon inserts. Again, rinse it really well. You can plug them in there and there. I usually don't use them. I would add carbon a different way, but you can buy these, and you have to you have to just buy their little cartridges. I think it's just a way for them to make more money, but usually I don't use these carbon inserts. I add carbon a different way, but you can do that. And then you turn on, and then next thing you want to do is put gravel on top of this undergravel filter. So your substrate, if you have fresh water, it's going to be some inert type of gravel that won't dissolve in the tank. If you have salt water or African cichlids, it's probably going to be crushed coral or dolomite or even limestone, some types, or you could even go with crushed shells. Usually it's going to be crushed coral, is what you're going to see today. That'll cover the bottom here, and the particles cannot be too small. You can't put sand on this thing. If they're too small, it'll clog up. Okay, so it has to be fairly large size granules. Then you turn on your air, and what happens is air comes down here, it produces bubbles, and then the bubbles will rise and then come out the front or top of this uplift tube, and it creates a current, because then water is pulled down through the entire aquarium, underneath the plate, and up through these uplift tubes. It works, like I said, very, very well at keeping the tank water circulated, okay, as long as you maintain it and don't let this gravel clog up. And the best part about this, so I mean, you're going to have the pH is going to be even throughout the aquarium, temperature is going to remain even throughout the aquarium. One big thing you need to be one big advantage of the undergravel filter is all of this gravel that you've put on your aquarium bottom, it serves as your biological filtration. Every single piece of gravel works as a tiny little filter media that'll allow nitrifying bacteria to grow all over it. So these work really, really well. When you clean an undergravel filter, you're going to take a siphon and just sweep off the top. Don't jam it all the way to the bottom of the down to the plate here and start sucking all the garbage out from underneath that. Just leave that there. Just sweep off the top, okay? Drawbacks. So there are drawbacks. They can become clogged with detritus. You can't use them with sand. If you don't maintain them properly, you can end up with insufficient water movement, and you got to clean them properly. Something else is you got to make sure that the same amount of air is going to both of these uplift tubes. Or what happens is maybe this one starts clogging a little bit with calcium and stuff. All right, well, now all the air is coming out of this one stops working. Let's say this line is a little bit longer than this line going to your air source. Well, air is going to take the shortest pathway. It's the least resistance. It's going to all go here. You won't get any over here. So you need to use what's called a gang valve. It's basically from your air source to a little contraption that you plug that air line into, and then from the gang valve it'll have a bunch of little valves that you can plug in the air lines going to these uplift tubes, and you can control how much air is going to each one of these. And as your air stones clog, you'll need to make adjustments so that you always have equal amounts of air flowing to both of these, or however many uplift tubes you have. Sometimes you might have 4 uplift tubes or more. All right, so there's going to be some maintenance with that. All right, internal filters. These things work very, very well. Typically, they're going to be a sponge filter like this or like that. And they're ugly, but they work. Another problem is that they float. So you're going to need to weight them down somehow. So these here, so again, it's just a big sponge. Then here's an uplift tube. There's going to be an air line going in here and it attaches right there. Turn it on. Water is sucked in through the sides. In the sponge, all of the little tiny spaces inside the sponge work as a biological filter. And then water goes out the top and you're continually circulating the tank. You get circulation going. They work really nice. There are some disadvantages. All right. Well, I guess here's an advantage. It does work as a nice mechanical filter because, you know, all the detritus and garbage will stick to this. So they need cleaned frequently. And the way you do it, you don't just pull this thing out of the tank and wash it under tap water. If you do that, you'll completely wipe out your entire biological filtration. You'll wipe out all those nitrifying bacteria because we put chlorine in our tap water specifically to kill stuff like bacteria, right? So the way to do it is when you're doing a water change, you'll take some tank water, put it in a bucket, and then you can take this sponge out of the tank, put it in that bucket, and then start squishing it. And then that will, and you swash it around. That'll get all the detritus off, and then you can put that back in the tank. That's the way you clean these things. It's a very easy mistake to make, taking one of these and rinsing it in tap water, and you just ruined it. Again, it takes a month to get that culture going, and if you got a bunch of fish and a lot of stuff going in there, you're in trouble. Your fish are going to produce a huge amount of ammonia that you won't be able to handle. So you have to be very, very careful with using filters like this. Also, they float. So again, you're going to need to add some kind of a weight to it. Or this one here has suction cups, so it'll actually stick to the side of the aquarium. Here's another one. And they make very good temporary systems. So if you're doing some research, you want to set up 10 aquariums, and they're just temporary, and you're going to run some trials, okay, or do whatever you're doing with your animals. They're good temporary systems as long as you have a bunch of sponge filters already cultured in a tank or a sump or some running system somewhere where they stay cultured. Okay, then you can just put them in here. They make good hospital tank filters. So if a fish gets sick, you want to separate it from the other fish and set up a temporary system. Okay, you can drop a already cultured sponge filter in there. Again, they float, so you need some sort of a weight to it. So this is basically, here's a sponge filter. There's an uplift tube here that you can't really see. And then to weight it down, a lot of times I'll just use a little piece of PVC, which it sinks, it doesn't float. Just drop it right over the airline. It helps hold it down. Here's another type of internal filter. This is a box filter. I love these things. Again, for a temporary short-term setup, you can build them however you want. Normally it's just like this little empty box here. It's got this tray in the bottom. There's an uplift tube. So you'd hook air up there. Air goes here, and then water rises there, and it just creates this current. So water gets sucked in through the sides of this thing, through whatever filter media you have in here, and then out the top. Here's another type up there. But you can see you can build it however you want. So you could put in zeolite, you could put in carbon, you can put in some sort of media that houses nitrifying bacteria. The way I usually build them is I'll put a bunch of filter floss in the bottom down here, maybe a layer of carbon, maybe you can buy these little ceramic beads that are for housing nitrifying bacteria. You can put in a layer of that if you want. And then maybe another layer of floss on the top, so it's everything's sandwiched between filter floss. There you go. The problem is you've got to take that filter floss out and clean it regularly. So you have to take this whole thing apart on occasion and clean it. And again, don't use any tap water to clean anything that has nitrifying bacteria on it, because you'll kill it. External power filters. So a lot of you guys see these. We use in the marine lab a lot of Whisper power filters, and the reason is because they gave them to us for free, and I'm very grateful for them. We actually wrote the company and asked for donations, and Marine Land very generously donated a whole bunch of these. So we have them on all our tanks. Actually, these penguins, you'll see that a lot of them have a BIOL on it. Okay, basically the way these work is you put it in your tank here, water gets sucked up through this uplift tube into this box back here, and then the box fills up with water. You can stick these filter pads and stuff in there that work as a mechanical filtration, because as the water flows through it, the filter pads may have carbon inside of them to help, again, pull out different types of waste or different compounds you don't want in there. And then the water will flow back into the tank. Okay, so these actually work very well. Again, most people think of a filter as this right here, like, yeah, I set up a tank, put a filter on it, and then all my fish died. Well, this filter right here has no biological filtration. If you used it in conjunction with a undergravel filter, that would be perfect. There's all your biological filtration. There you're adding some more circulation, and basically you've got nice mechanical and chemical filter is a supplement to the biological filter. Okay, but they do produce good circulation, but you have to worry about that biological filter. These parts, let's see, they're impeller driven. And I'll come to that in a second. Let me just show you these. So there's your BIOL. This is Penguins or Marine Land's way of addressing biological filtration, and I was highly skeptical when I first started using these. And I've actually been using BIOLs for a long time. They've been around a long time. And I'm always concerned the algae is going to grow on these, and they'll stop turning, and they'll get all gunked up. But they do pretty well over huge amounts of time. I've had them for many, 10, 15 years, and they seem to just keep working fine. Occasionally they might stop turning, but you can usually clean them up a little bit. And as long as this thing's turning, this is like a paper pleated cartridge you don't have to replace it. You always just leave it there. And nitrifying bacteria grows on it, and they actually seem to work pretty well. Here's a better picture of these BIOLs. And sometimes you'll see huge ones in big sumps and tanks. But again, water's pulled in this one here. Water's pulled up through the middle, fills up the box in the back until it overflows and runs back into the tank here. And you can see the BIOL turns. The ones that I really like, and we only have a few of these in the Marine Lab, and this is usually what I would buy if I have to buy some sort of a hang on the back power filter. I get these Hagen AquaClears, and again, water's pulled up through this J tube into this box here, and this box fills up with water, and then it overflows back into the tank. The reason I like these, you can just build these. This is just a big tray that you can remove. It just slides in. You can pull it out and build it however you want. You can put in bags of carbon, bags of zeolite, any GFO, any media that you think you need, and you just buy little bio bags, just a little bag that you put in whatever media you want, and then just drop it in there. You can stuff filter floss in there if you want, you wouldn't want to pack it in too tightly, or you can use a sponge, okay, which is going to help with nitrifying bacteria. And you can see here, this is a bag of carbon. So you can build it. They're more flexible in the way you can build them and what you can put in it. You could put those little bio balls or ceramic beads or some sort of media in here that would handle your nitrifying bacteria. All right, so here's an impeller. So these pumps are impeller driven. A lot of the pumps in aquariums are impeller driven. This is what an impeller looks like. This is a magnet right here. Let's see if I got a picture there. That's a magnet. And then there's this metal rod that goes through here, this little rubber boot on either end of this magnet. And you drop it inside the motor. Okay, and then inside the motor, it's sealed off so that water isn't seeping into the motor. And on the other side of this little cup here it turns this magnet, which again turns this propeller, which creates the current in your tank or your filter. So this is actually a power head that you're looking at here. There's a lot of cases. I'm sorry, this is a impeller. That's a propeller. Same thing. It's just instead of pulling water in and up, it's pushing the water like a propeller would. So, but it's moving the same direction. It functions the same way. So here you have your propeller pushing the water. An impeller, this is the way a lot of your pumps work. There's that little cup, okay, that I was talking about. You drop your impeller in there, and the motor turns the impeller. Water gets sucked in, goes around here, and then discharge. So this is the way that most of your power heads work. If you have some reef tanks with a propeller, it might look like this. One thing you need to know about these impellers and propellers is this magnet here can get covered with all kinds of gunk. This stuff here, this slimy stuff, is not a big deal. It's just algae and stuff, detritus. You can wipe that out with your hands or a rag or whatever. This magnet right here will get covered with calcium and other deposits, which can make this thing stop turning. Usually when a power head or one of these pumps stops working, usually to fix it, you just pull the impeller out, scrape this off, maybe even with a razor blade or some, pair of scissors or some metal object. Scrape all the gunk, the calcareous encrusted gunk off of it, drop it back in, and it works just fine. Something else you should be aware of: if you have one of these things that is running in air, let's say you have a sump in your aquarium, this is your return pump, and your sump goes dry, the water level drops too low for too long, this thing no longer has water. There's no water in here. It'll heat up. This magnet will expand and crack. If it's really bad, it'll freeze up inside here and you won't be able to get it out. If you can get it out, you might be able to just take pliers and pull this out. You can just replace the impeller and you're fine. You're back in business. But there's some times where I've seen them, they'll freeze up in here and you can't use it anymore. You have to throw the whole pump away like that. So you can see it was run dry. It expanded and cracked. All right, so here's some different types of power heads. These are just to create circulation in your tank. So this one's using an impeller that pulls water up through here and then out. This one's a propeller that's just pulling water in through the sides and then pushing it out. Canister filters. I hate these things. Some people really like them. There's another type here. But they actually work depending on what you want, but they just require a huge amount of maintenance. So basically, you're pulling water from your tank, which goes down into this box here, and then there's whatever filter media you want to stuff in there, and then it pushes it back out back to your tank. They're nice. You can move them underneath your aquarium or out of the way somewhere. They do produce great flow rate, and you can build it however you want. You can put filter floss, carbon, zeolite, nitrifying media, bacteria media, whatever you want. But really, you got to take them apart regularly and maintain them, or they start to get pretty nasty. Here's another one. You can kind of see through the plastic on these, but again, water's pulled down here, and it's going through all this media. Those are some of those ceramic beads there for nitrifying bacteria. It looks like filter pad there. This is like zeolite or carbon here. Made another filter pad up there to keep this sandwiched in here so it stays in the filter. And then returns back to your tank. So again, they are nice that they are very flexible in how you build them, and you can get what you want out of it. But they do, if you don't do the regular maintenance, it's going to be a mess. And sometimes, you'll take the top off, and then these little clips hold this top on. They just will start to leak and cause problems. I don't know. You can make your own decisions on that. I stay away from them. I think that they're a hassle, and I think there's easier ways to filter a tank, but some people love them and swear by them. Here's another type here. It's just showing it's got a bunch of BIOL balls for your to handle the how to house nitrifying bacteria. There's another type here. So lots of biological filtration. All right, pressure filters. So sometimes it'll be something like this. Looks like a canister filter, but instead of having zeolite or carbon or whatever in there, it'll have one of these pleated filters, or they could be made out of rag like this. And there's different micron meshes. Some are finer than others to take out finer particles, but you'll run into these. They work really nice. So you put them in your tank. Sometimes people come with a water polisher. Let's say you just do a water change and the tank's all cloudy and got just detritus everywhere. You can drop one of these guys in here, and that will help strain out the very fine particles. And then after a little while, what you're going to need to do is take this pleated cartridge out and bleach it. So when I was a professional aquarist, we kept these on most of the large aquariums, and these canisters were massive. They were probably like a big swimming pool cartridge. If anybody has a swimming pool, you might have a filter that uses these types of canisters. And then you got to bleach it. Not pure bleach. You used a mix of bleach and water, and then let it sit overnight, rinse it off really, really well, let it sit out, and let any residual bleach evaporate. But they need quite a bit of maintenance. When I was in a professional aquarist, we'd change those about every 2 days, I believe. And there's a bleach bucket. So one of the many jobs in the marine lab is the bleach bucket system, which is extremely important, not only to clean off, filter cartridges, but it stops the spread of disease in the lab. So anything you use, a net or anything you really stick in your tank, you want to throw it in the bleach bucket system to kill any parasites or diseases that could be spread around. And then things need to be rinsed, and then they got to let them air out. All right, diatomaceous earth. Sometimes you'll run into this. I don't use it, but basically it's just this fine white powder that you throw into your aquarium, usually in conjunction with some pleated cartridges like this, and the any dissolved organics are going to quickly stick to this powder, and the pleated cartridge pulls it all out, and it makes your tank really look really crystal clear, like almost sparkling clean. I don't use it. Some people love it, but again, sometimes you'll hear people talking about a water polisher. They may be using diatomaceous earth with some of those pleated cartridges. All right, on to the wet, dry, and trickle filters using a sump. So in this picture here, you can see this is a newer version of a wet, dry, or trickle filter. And basically, some people, they used to call it the Dutch system. But basically, it's water comes from your tank into this drip tray. The drip tray has a big piece of mechanical filtration or filter media here. So water will drain through this, which this needs to be taken out and rinsed off every couple days. And then the water drains over these BioBalls. There's your biological filtration, runs down into the sump. Down here you can have, they've got some chemical filtration going on there. It looks like carbon and whatever else they got here. Maybe GFO, zeolite, I don't know, whatever you want to put in there. You might have some heaters down here. You might have your protein skimmer, whatever, down here in this sump. And then the return pump taking water back to the aquarium. A couple things about these is the water level in your tank will stay the same, which is nice because you're drawing the water off, and there's a few ways to do that. We'll get to that later. But water evaporates a lot. You probably figured that out by now, and you're continuously adding fresh water to your system to replace that water that's evaporated. Well, you won't see the level in your tank going up and down. You'll see instead the water in your sump going up and down as the water evaporates. And you just have to make sure that you always add water to your sump. In fact, any additives you put in should be to your sump. Let's say whatever you're dosing, add it to the sump. Some drawbacks, if your sump is not too big, or if it's too small, what can happen is, let's say you turn your return pump off. It's no longer adding water to the tank. Okay, the tank continues to drain into here, into the sump, and then the sump will overflow and flood the area. Or if some things can go wrong down here and you can create floods. They can be an electrical hazard. Let's say you let your sump go dry and you got a heater down here that starts melting stuff and causes problems. That's something you need to be concerned with. Some people look at a filter like this and consider it a nitrate maker. With all these BioBalls, you could end up, if you're not doing a lot of very good maintenance, you can end up with a lot of nitrates in your system. And you want to make sure you have a pre-filter and that you're cleaning it like regularly, 3 times a week. So this could be considered a pre-filter, this little filter pad up here in the drip tray. There's other types. So here's a couple ways to get water out of the tank. One, you drill a hole in your tank and you put in a bulkhead, and then you can see you put in something like this. This is inside the tank. Water's running through here, maybe there's a mesh or a sponge in here that works as your pre-filter, and then water runs down, and you're going to pull that pre-filter out frequently and clean it. Another way would be, sometimes you can take a big sponge and stick it right on here inside the tank, which needs to be removed and cleaned frequently. Another way to get water out of your tank, if you don't want to drill a hole in your aquarium, is you use a pre-filter that looks like this. And this is inside the tank here. This is behind the tank, and then that's the glass. So you're looking at a side view. And then you've got a J-tube here. Okay? And you stick the J-tube in, and then you have to there's different ways to do it. This one has a vinyl, has a siphon built into it. Usually what you have to do is take a piece of airline and feed it up through the tube here and start sucking the air out. You have to add a little bit of water here. And then once the water goes up and it'll connect, it creates a siphon that you need to keep the siphon going at all times. And then water will start draining through, here, and then up through the uplift tube down into this back box over here. And then it starts filling up with water, which then will be sucked in through here and then down to your sump. Okay? And then if you turn everything off, this siphon, if everything's working properly, this siphon should maintain itself. You don't have to start it every time you turn your tank on and off. This siphon, as the water stops flowing, it'll just stop. There'll be water still here. And then you turn your return pump back on, water starts going, this level starts rising, water starts going again, and it should just start back up. Now, pre-filters, a couple ways to do it. Usually, you'll see just a big sponge. So here's the inside of the tank box. Here's the behind the tank box. There's your J-tube. So water's coming and filling this box up, and then this is usually a big strainer, and then the sponge sits on top of the strainer, and that works as your pre-filter. Or here's another version. This is actually inside the tank over here. This is behind the tank. And as water flows into this pre-filter, it goes through a sponge, and then up and over, and then back, and then into the behind the tank box back here, and then down this tube. So there's a couple ways to do that. Usually I see this here, but all right, so this is just showing you the same thing there. So there's your water level, and J-tube fills up the pre-filter through the water, strains through the sponge, and then down to your sump. All right, so here's another one. This is showing filter socks. Instead of using a drip tray, you'll see these are actually more common nowadays. But I think that the drip trays are coming back. People are starting to decide they really hate these filter socks. But again, water would drain, so would drain from the aquarium down to your sump, and that filter sock could be considered your pre-filter. But again, you got to pull that out frequently and clean it. And then this is your sump, so you might have a sponge in here, protein skimmer, return pump, that kind of stuff. Here's an old-fashioned one. Again, there's a hose going to a drip tray through your bio balls down into your sump. There's a sponge there. It's going to help or serve as mechanical and biological filtration. You may have a heater here, and then an old skimmer that these things were junk. They didn't work very well. Well, they worked better than anything else, but they did not work well. And then there's your return pump. All right, so that's the end of that section.